Hi, everyone. I guess we're going to cover grids today. And I'm going to start in Grasshopper. The Grasshopper just shut down, so I'm just opening it up again. And different ways to kind of create grids and then use grids as the sort of base for creating geometry on top of, and then kind of morphing that onto surfaces. Okay, so from the top menu, grids appear in vectors, and here's the grids here. There's a hex grid, radial, rectangular, square, triangular. So if I start with a rectangular grid, and I'm going to make this half the screen again, and I'm just going to maximize my top view. So this rectangular grid has some inputs. I'm just going to create number sliders of 100, and the S is the size of the grid cells X and Y, and the E is the number of grid cells X and Y. So I can use a rectangular grid to do a square grid, and use two different sliders for the extents, and I can slide them back down to 10. Just double click there, and I have my square grid. So the outputs of this grid are the grid cells or the grid points. And if I was to do a points list, which is going to sort of let me see the numbers of the points, or well, let me just do that first. And it needs a slider of to set the size of the text. Okay, so you can see the points are currently in these paths going vertical from 0 to 10, and they're already sort of organized in these vertical paths. So if I was to do a NURBS curve and just connect these points and turn off the geometry so I can see what's happening, it's just going to connect them on that path. And if I was to flatten all of these points, it would connect all 100 points together. And if I turn back on the points and turn down the text a little bit in size, 0, I can see now the points are numbered from 0 all the way to 120, because we got the +1 that I referred to. And flip matrix is great to see in this example, where it's just going to change the X and Y. So if I turn off the flatten, so they're still in their vertical paths, this is going to give me horizontal paths. So I can see all that sort of in the just regular grid. If I wanted to create a grid from scratch, I could use the construct point, and I'll just turn this off. Construct point, and if I create some number sliders, I'm just going to use the same for X and Y. So you can see the point move there. That's just X is 30, Y is 30, and there's my point. If I use a series, because I want a series of numbers, and I switch this slider being to the C, which is the total number in the series. And now if I hover over here, I can see I have a series 0, 1, 2, 3, all the way to 34, and replace that with X and Y. That means now I have 34 points where they're moving in this diagonal line because X and Y are the same value, but it's just creating 1 point. So to create a grid, I have to cross-reference the series of information. So I can just put that into A and B, and then, yeah, and there's a sort of grid manually. And the reason you might create a grid manually is if I was to put an expression of mathematics or any sort of something in the middle between the series and cross-reference, and rather than go proportionally 0 to 10 or 0 to 100, sort of move exponentially or distort the grid that way, and there'd be one way of doing that. I want to just move on rather than do that because it takes a little time. The cells coming out of the grid are different. So where the points are organized, as I've shown, the cells are squares. And if I was to deconstruct, or they're curves, so I can just use control points. So I can deconstruct curves, but let's just do control points. And I want to see I'm just going to move this points list. And control points just lets me see the control points on each one of those cells. So we have a square of points, and I want to see the numbers of those, the number like of the point in the list. I'm going to make this much smaller just so it's obvious. Let's move down to 3. And this is actually going to be it's labeled on top of each other. So, oh, this is turned off. So I can't see it properly because it's all on top of each other. So I'm going to use the list item command, which is going to separate some of these things for me. So let's just turn this off first. So list item, to get the first item in this collection of paths, is going to give me the 3 cells on the bottom. So I want, if I just want to see one square, I want to list item twice. So I'm kind of saying take the first path, which is a row, and then take the first, actually I want to flatten this. Yeah, so now it's just 3 cells flattened. So I want the first of those 3, and that's done using list item twice to flatten. And now let me see the control points of that. Let me turn this on. And there we go. I can see it properly. So it's got 0, 1, 2, 3, 4. When you're doing Python in Grasshopper or Python in Rhino, to make a closed cell, you don't just do 0, 1, 2, 3. You do 0, 1, 3, 1, 2, 3, 4, where 4 and 0 are equal to each other, and that makes a closed shape. So it's giving us the 4 here, which we might want to remove. Which, if you remember from last week, we could use co-index or co-nth and remove that 4th point if we wanted. 12.4. Or we could call -1. Might be smarter. What are we getting out of this? So actually, sorry, control points. There we go. So using call index, we've got rid of the last point, so we just got 0, 0, 1, 2, 3. And if we were to make geometry by connecting these points in whatever arrangement we want, it would repeat for every single cell in the grid. And I'm just going to move to a PDF where I've sort of done that. And you might have seen the GIF already. So let's see. So if we had 0, 1, 2, 3 as points, and I was to do NURBS curves where this curve that I'm hovering over here is just a NURBS curve using the points 0, 3, 2. This one's 0, 1, 2. And it's just 3 points, and it will automatically give you that curvature. And if I was to, using the cells, create lines between each of the 2 points and then find the curve middle, then I would sort of, as a separate list, have these red points, and I could, for the sort of midpoints, and use that to generate further lines. And let's say I drew these lines in my cell using 0, 1, 2, 3 and the midpoints. then it's just going to repeat for the grid, whatever size I make it. And I'm just going to show you one I did earlier that if I was to shift around these points within the grid, then the geometry will just kind of keep holding to those points. So that's Grasshopper. So there's the kind of system. And if I change the seed of the random, you can see it sort of just shifts around, but the geometry is kind of held to those grid points. And this is the maximum deviation from the normal. So if it's 0, no movement, and a little bit of movement, and then randomize the points. So that's what we're going to do first. And then a very quick thing at the end is just to take any geometry in curves and, oh, I don't have a surface, and basically just morph it to a surface. And an example of that is just, there's a surface, like a kind of tower kind of thing, and it just took the geometry we did and just wrapped it around there using a domain. And I just turned off some of the geometry so it's clearer on that side. And then hopefully there'll be time at the end that if we were to split a surface, it's slightly different, but we're ultimately producing a grid on a surface. And we have the points again using kind of a cell or an isotrim, 0, 1, 2, 3. And then we were offsetting that surface and did the exact same thing again. So then we have 0, 1, 2, 3 and the offset 0, 1, 2, 3. And then made surfaces connecting. So we have 8 points in our each sort of cell, kind of combo of cell and offset cell. And make this kind of surfaces to make some geometry there, and maybe choose kind of offset from the base triangles to make sort of windows opening, and can vary those, the offset based on whatever parameter we want. So we have small windows and big windows. And then there's an example of divide a surface by 10 by 10. So we have a grid of, or sorry, 5 by 5 on this first one. And then to control the offset distance of the window size, just use the Z coordinate of the centroid. So the height of each window is determining how much it opens, it's just multiplying by it. And then divide this one by 10 by 10 and this one by 20 by 20. And when you're up to this one on the right here, you can see if I was to go much further, I would have a very slow computer because there's a lot of geometry being calculated. I think this is like 40 by 40, I can't remember, or maybe 80 by 80, you know what it is. And I could also choose to open one side and not open the other, and then randomize the pattern. So split the thing into, I think this is 35 by 35, or and just pick any of the windows, but still use the offset. So now I'm going to go to Grasshopper, and we'll, if anyone has any questions, let me know. All right, so I'm just going to delete everything and do bifocals, which just lets you guys see all the names of what I'm using. And so create a rectangular grid, and maybe I should have left this stuff in there. Okay, so I'm just going to start with 10 by 10, but I like to have the sliders bigger in case I want to slide them up. later. And I want the cells, and I want the points within the cells. So we can use the control points that we had earlier. And then if I was to list those points, list item, and I don't really need to call it because I just won't use it. So I'm going to use just the pluses here. This sort of little plus button here, which just gives me list the points in order of 0, 1, 2, 3. I could create separate items and put the number in 1, 2, 3, but it's an inefficient way of doing it. So now I just have all those items in one. And now I can make some NURBS curves. And I'm going to need to pay attention to the order I put these in. So I might turn this down to 1. So it's just easier to see. And now this is point 0. This is point 1. And I can change this degree to 2 because it doesn't have enough points to be greater than that. Would need 1 extra point. And then create another NURBS curve and so I'm not going to use, I mean, this would be the same as the first one, but I might just minus that off there. Is that? Which one have I done? I want point 1. Yeah. Okay, so that does all of them. I guess the last one. So now if I move this up again, it should repeat, yeah. Let's just do, and I can turn off the control points. And then to get the other kind of geometry, it's somewhat repeating, where it's just kind of finding the midpoints and sort of stitching together curves of the same kind. But that's kind of the main part of the exercise to get started with first, just to kind of get that far. I guess, or maybe I'll just quickly do. So I would use a line from, I might just Control G, group that, and move it to sort of side. And then form several lines. And then curve middle for So now I have points, these points, and I can kind of put whatever geometry I want into my cell and have it repeat there. So if everyone could kind of get started and get that far, and let me know if there's any problems, and if someone wants to share their screen, that'd be great, and I can sort of help someone out. Matt, my index, close but not exact. Okay, so I mean, our basic idea with the NURBS, or I don't know if you can share your screen, but we have our points 0, 1, 2, 3. Don't need the 4, and I mean, you can do whatever curves you want within the cell, and it's just going to repeat. That's kind of the idea of it. But I just did, you can kind of like think if you were to draw it manually, 0. So this is 1. So 0, 1, 2, then 1, 2, 3, then 2, 3, 0, and then the last one I went backward. I guess I went 1, 0, 3. It's also just a good exercise to get used to working in lists, getting used to the idea that the cells are sort of grouped or in paths, and therefore this is all going to repeat itself. And I think in the example in the PDF, I actually created the area centroid for each cell, which is just give you the center point of whatever geometry, and build some curves on top of that. So you can kind of build whatever curves you wanted. There's no need to make it look like the one I did, but.
Yeah, I was going to comment a class or two ago. I like the the sort of when you hold down Shift and the little plus overlay icon, but I happened to miss that a couple of times. But I think I got it now. It looks like Photoshop when you hold Shift. I like that.
Oh yeah, just I guess just a quick overview on the different ones. So Control, hold it down. That's going to cancel one out. One that becomes very important is Control and Shift. So this is going to break this apart. But that basically moves all the stuff from one to the next.
Oh, cool.
And that's useful if, like, let's say, right at the beginning of your thing, you had a square grid, let's say, or a rectangular grid, and you had all this geometry later on. And it wouldn't work for this example, but it might work for another one. And you just wanted to grab all the beginning stuff and drag it to a different one, to a hex grid. Or, you know, there's different reasons why you might have like a different variable.
Yeah, I see.
But Control Shift to that. And then one last one that's kind of important is Control Alt. And that's where you click on a certain, so if you download one of the definitions that I have uploaded, Control Alt on something you don't recognize, and it just gives you the arrows of this here is belonging in the curve. If you see that arrow at the top and the circle that's circling it sort of here.
Yeah, I think I'm about. Oh, good. Thank you.
Yeah, without the shifting, that would be pretty hard to do. And if you don't hold anything, that replaces it, which is useful as well. Cancels out all the existing wires. So I'll just leave it for a few minutes. So you guys can just do that much.
So I've actually got that much done, and I'm happy to share my alternate screen.
Just to, oh yeah, I guess let's check it. Just to correct, area centroid is what you type in Python. In Grasshopper, it's just the area component if you wanted it, and you basically do the area component on the cell maybe, and that would give you the area of the geometry, like as a number, like measured sort of area in meters squared or millimeters squared, and more useful to see. So we could use that centroid to build geometry to all the control points. Line from C to all control points. Actually, okay, well, this is meant to be correct. Yeah, yeah. Okay. So there's from area to all control points. I had to graph the centroid, just giving it some path. All right, so let's see someone's screen. I don't know who was speaking there. I can't tell. I think maybe I need to stop sharing. All right, that's perfect.
So far, so good. Thanks.
Yeah. So the nerves have a degree of 3, but it works. I mean, it doesn't matter. That's just why they're orange. All right, so I'll just jump on to sharing my screen again, and we'll go to how you would morph geometry. And morphing is kind of like just stretching it like a fabric and just wrapping it around something. And you can do it with any curves or surfaces or B-reps. Let's see. So the first thing I'm going to do, and it's sort of useful, is I'm just going to make curve as this like little container. I'm just going to drag everything into that as a sort of kind of almost folder to just wrap everything in. And I'm just going to keep this X curve as well that I did. So now I can turn all of this stuff off. And now I just kind of have this like kind of like a dam that can be on and off for the whole thing. And I want to use surface morph. And make sure I get the right one. I want this one with you know, like sort of a white and yellow rectangle. And there's quite a lot of inputs to this. And basically the G at the top is the geometry to deform. So that's going to be my curves over here. Then the reference box to map from is a 3-dimensional, it has to be 3-dimensional box wrapped around the geometry I'm going to morph. And that's sort of a bounding box. And it's just kind of the what's being grabbed. And if you think about like some of the Adobe software, if you're familiar with it, it's kind of like the transform that you might warp around the edge. And then the surface to map onto, which is my tower shape or whatever shape I want to put it onto. And then I need a U and a V, which is the kind of domain of that new surface. And then WU is surface space W extents. Kind of confusing the way it's written there. It basically means the thickness projecting from the surface. So almost like the Z value from the surface, where XYZ is for the world grid, UV, and then W is the XYZ equivalence when talking about local surface dimensions. So first thing to do is get a bounding box, which in Rhino you just type bounding box, and it's the same in Grasshopper. And we want this curve geometry to do a bounding box on the curve. And there's this sort of setting on bounding box where it says per object, and that's not what we want because that's producing tons of boxes, 900 local boxes. But if I right click it and I change it to a union box, most often I want a union box, that's now 100 boxes because we still have some paths here. So I can flatten something this side or this side. I'm going to flatten it on this side. And now one flat box. So I flattened all the paths and it's a union box, which has gone around the absolute edge of everything. And that's what I need for the reference box. So I can plug that in right now. The geometry I'm going to deform is going to be this one. So we still kind of need a bunch of other stuff. So if I go into perspective view and I need any surface in Rhino, so I'm going to draw a NURBS curve using points. So there's just a flat circle, or sorry, kind of elliptical NURBS curve. And I'm just going to copy paste that using Control C and V. So I have two curves there now, and drag one up using Gumball, which is this thing with the arrows. And then do rotate. And you can create any surface you want to do. Okay. And then I'm going to loft those to create a surface. If what I just did is really unfamiliar to you because this is more Rhino than Grasshopper, just create any surface like a sphere or just any surface, but it's kind of like a tower shape. Maybe I might just put this way bigger. If anyone has any problems, I'll just help you with. So I want to bring that into Grasshopper. So I create a surface and then right click, set one surface. That's my surface. And you always get this clashing of the surface with the Grasshopper surface because now it's sort of two. So I select the surface and type hide. And I can just select these two curves and type hide as well. That was in Rhino. So now I have this surface, and I basically want to project this geometry onto that geometry. And the domain of a curve is usually 0 to 1, but depending, you can get more than that. And surfaces have a domain in two directions. So the first thing I can do is deconstruct domain. And I want the area one, which is this square with two arrows going off. And that basically is going to tell me that this domain of the surface is not from 0 to 1, it's from 0 to 136 on this, or well, it's, yeah, U is from 0 to 136 and B is from minus 239 to 0. So that's the domain UV area coming from this surface. So if I was to change the surface, that would automatically update. And then that is the surface there. And the W is basically the projection off thing. And I don't really want to, I think if I just set it as 1, it will do something that I want. Oh yeah, sorry, it has to be a domain. So construct domain. And I think it can just be a regular B2B. So now rather than saying this is 100, it's now 0 to 100. And that still doesn't work. Reference space volume cannot be 0. think I just need to have some thickness on this. Scale. First. Yeah, okay. So I just gave the box a thickness using an extrude of these curves. There's just one way to do it. The geometry being morphed is still just the curves, so they're not actually extruded. But if I was to take the extruded curves as the geometry, I guess I could do that too. I might slow down my computer a little bit more if it doesn't finish it. But that's the basics of extruding way too much. Interesting shape. So I guess people can get started doing that, and I could control, oh, yeah, okay, so the domain was 100, which is basically means it's going to morph that geometry we initially had, and sort of, we're using small dimensions currently, so it's giving it a thickness of 100. So if I make that 1, it should shrink it down a lot. Okay. Didn't actually intend to do thickness, but 50%. So I can turn off the surface because it's been getting in the way, and it's a nice little complicated facade there. And basically just takes any geometry and sort of skews it to the surface, whatever surface geometry we created. And if I did these curves in Grasshopper as opposed to just drew them really quickly and did the loft in Grasshopper, I'd be able to mess with the height of the tower and do it that way and sort of stretch this really fast. If that makes sense to everyone. So does anyone have any questions, and do people want to draw that? And if anyone wants to share their screen while doing this, it'd be great. I'll just guide it.
My problem was drawing the surface in Rhino. I'll go back and do your other course, but I wasn't able to integrate it in between last week and this. The surface is probably really easy, and it'll take you.
So one example, we'll just make this easier. If you just kind of hover over this sphere, and let's say we just create a sphere, and just a center point and a radius, and then create surface here, and hopefully this should just update to the sphere. It's probably the easiest surface to create. Yeah, kind of nice, cool looking.
Yeah.
And then I say I want to do select and type hide in the Rhino commands to kind of hide it. That's probably an easier surface to create. Does that make sense?
I was looking away when you said just select or just click and create. There was the surface thing, and I just missed what you.
So,
on the left. There we go.
Box here, and you kind of hold left click to sort of bring out this
choices.
menu.
Gotcha. Yep.
And as long as you hold and then sort of leave it alone, it will sort of remain hovered here.
Yep.
And then just click this third one, which is a sphere with a center radius. The fourth one is a sphere with a diameter, just different inputs. Most solids are poly surfaces in Rhino because they need more than one surface, but a sphere is sort of one of those exceptions that is just a single surface.
Sphere, center radius, got it. Okay. Where did you go? Oh, I just have to click center and radius. Ha! Look at that. Oops. Then click again. Okay. And then select.
So I'll just leave that for a few minutes. Keep me updated if anyone has any problems or when you're done. And then I'll move on and I'll show you the last example of working with Isotrim and sort of on the surface directly.
James, there was a question in the chat about linking the Rhino geometry to the Grasshopper primitive.
Yeah, that's me.
Okay, so right click and set one surface is how you do it. Set multiple surfaces if we wanted it to do multiple surfaces. So I'm just going to unhide, show in Grasshopper. So that has these two different surfaces that I created. And just right click, set one. Or I can set both of them. And
then it's is it a left click in Rhino when that's waiting for the surface you're selecting?
So right click, then left click for set one surface, and then kind of select it, and it doesn't need a click actually, or sorry, just left click to select it. It doesn't need an enter. And for multiple surfaces, it needs an enter.
Got some Blender habits too, where I'm just using the right click.
Yeah, well, that's always slightly different. I used to do stuff in 3D Max and Maya and Rhino, and they're slightly different in terms of just orbiting and basic controls.
I have cylinders, which are just kind of wireframe geometry. Is Rhino consider that something that is not a surface?
Say again, you've got
cylinders. The cylinders that are wireframe, but they don't look. It looks like.
So for the can you still see my screen?
Yes.
So on this perspective view, right click and do ghosted view.
Okay.
So all geometry in wireframe is kind of like used in wireframe is, let's say, used in more 2D views to be kind of like a CAD program, and then shaded, rendered, ghosted. And it's kind of nice to sort of flick through these. Arctic is kind of like a kind of rendered white background kind of thing. But ghosted is the most common one, which is just surfaces with transparency. Shaded is surfaces without transparency. And then in Rhino, select the surfaces and hide, which they can just hide and show to, or isolate as well if you want to do the same. So at the end there, if I was to go right back to the beginning and change the number of cells in the thing to 20, the whole thing should update. Or actually, my computer's a bit slow. So. Yeah, there we go.
Pretty close, and I've got a surface, but my surface morph is objecting, and I'm not sure. I don't remember where he went from in the last step or the last piece to fix the surface morph.
You want to share your screen, or?
Sure, yeah.
I'm going to stop sharing. I think I just manually stopped. Okay, let's just zoom in on the surface morph and read the hover kind of thing from the top right corner of it. That little speech bubble, just hover over it, yeah. reference space volume cannot be 0. Okay. So currently a bounding box, given the curves we've drawn have a thickness of 0, which means they are sort of a virtual geometry. They have no real, for surfaces to work, they have to have at least a thickness of 1. So somehow we have to get that box to have a thickness of just the slightest amount. So the way I did it was I extruded the curves and then put that into the bounding box. I just wanted anything. I mean, you could extrude the bounding box as well, or scale it, or just
I remember hearing that.
ways we could do this. So leave curves. But we just need it to have some thickness, even if it's 1 millimeter.
Just extrude.
So it's a volume. Yeah, extrude. Just one. Sorry, just extrude the third one up there.
Oh, sorry.
Just extrude with no extra words. And that works for both curves and surfaces, I think. So now if we put the curves into the extrude and then just give it a direction, which is just a unit z vector, which is fine. It's just 1 unit of z, and that's cool. If you did unit x or unit y, it would just stretch it on the xy axis and would also have no thickness. So that wouldn't work. You don't actually need the 1 because it's just.
Oh, sorry.
Yeah. Well, it's fine. I mean, it's just.
And that goes into the bounding box.
That goes into the bounding box because we're going to replace. We want the bounding box around the extruded curves, not the. And just thinking back on this in retrospect, we're probably creating unnecessary computation here. We don't really extrude those curves. It's kind of a, we just really wanted a box. But anyway, it's done. And so did that work or not work?
The morph is happier. I just haven't morphed it onto the surface. So, oh, wait.
Wait, the surface. Is that surface labeled as the sphere? It is? Oh, yeah, it is. Can you just turn the sphere off so you can see is anything?
There.
Or on this component on Grasshopper, just do a Control Q to turn the preview of the surface off so we can see.
Oh, look, there it is. There's something.
Oh, I must have a lag on the video.
Might be there. Yeah, it's off. So there's the yellow, which I didn't figure out how to turn. There's just 1 or 2 lines in there.
So, okay. Just make the domain, this shouldn't really matter.
I can zoom
just
in.
select the curves, just select the curve component in your Grasshopper. And that, does that select the whole, my video is on a lag from when you're speaking. Does that select the
Sorry,
whole?
there it selected it. It didn't the first time.
But does that select the whole square there? I don't know.
I think so. You mean the grid?
Yeah.
That's flat? Yes.
Okay,
Yes, it did.
We're going into the surface more. one a little, what did I do differently? Oh, you know your bounding box?
Yep.
So your bounding box, I think you might have the wrong one. So can you just right click on bounding box? Oh, my video's lagging from you. But you basically want a union box and make sure that the bounding box is one box around all the geometry, because that's sort of the box that you're grabbing. And what you don't want to do is grab each one individually.
Right.
So union box, and then make sure the extruded curves are flattened as well.
Oh, haven't done that. No.
Because otherwise it's going to do the paths individually as opposed to flatten all the paths and just do.
There we go.
How does that work?
It worked.
Okay, there we go. Figured it out. Okay, so I'm going to jump on now to go back to my screen. And this is good progress. So I'm going to turn all this stuff off that we've done. And show. So I'm just showing the Rhino surfaces. So I want a surface, if you want to use the sphere, if you want to use a lofted tower, it doesn't really matter, just any surface. And I'm going to start a sort of new example, turning off the previous one. So set one surface or both surfaces and hide this geometry. Okay, so now I have this one surface. So we know kind of domain is going in two directions across the surface, and I want to divide the domain this time. And I want, I think there's multiple divide domains, but I want divide domain squared, so it's sort of area. And I want to divide the domain of the surface. And that's sort of the, it's not something that's visual, it's sort of dividing the numbers that are the top and the bottom of the domain in both directions by whatever numbers I put in here. So I'm going to create a slider, or I guess everyone should be watching now rather than doing it. And I'm going to turn this down because I don't want it as high as 100. Or actually, let's say I can do 10. And then there's the Isotrim component, which is actually going to do our sort of splitting of our surface into cells. And it wants a surface into its S, and it wants the domain, which is our divided domain there. So one surface is on top of another surface, giving us this clash. So I'm going to turn off the first surface in Grasshopper, Control Q, so I can see this better. And you can see these sort of red lines, and that's sort of the, as I turn this up, sort of splitting that surface into there. And I guess I don't want this to be 0, so if I want to do that, values minimum at least 1. So I can see it's very sort of slight. I think it would be better in green. But you can hopefully see that this grid is changing there. And that is similar to what we had before, but now the grid is on the surface and we're creating geometry where the points 0, 1, 2, 3 are on the surface. So let's leave that down at something small, like 8. And I'm going to offset the surface now before I move ahead. And that's this one with the orange offset surface. And I need to plug the surface in, creating a new surface. And then I want the exact same thing to happen again. So I can copy that and just drag it down. and I want to replace the divide with the new surface and replace that. And in general, I kind of said this before, but I always want the fewest amount of sliders possible, so that if I change the UV count, the sort of number that's dividing the surface, or isotrimming the surface in the top one, that the offset is the same amount. So I don't really want 2 sliders. I can put that in. And if I had a copy paste just these 2, it would have automatically been connected to this slider. Okay, and I still don't have anything visual because I have not bothered to give an offset distance yet. So I'm going to create a 100-point slider, but turn it down to something small, because I think this is. Okay, and I'm going to Control Q off the surface because they're clashing. So I can kind of see the 2 surfaces there. This is my offset. I'm just going to change the name of it to offset. And I can see that's offsetting, and both of them are being trimmed by, or created the number of cells. And if I wanted a different UV, I'd create 2 sliders, but I'm fine with the same number. Okay, so this is outputting a number of surfaces, and I can deconstruct. I usually use deconstruct BREF surfaces, sort of BREF, and that gives me faces, edges, and vertices. And I'm going to do both of them. I could put them into one, and then I'd kind of just make sure they're on different paths. But I'm going to split them up again, so I'm fine with using just separate components. And I want to list item. And so this is faces, edges, and vertices of these cells. The vertices are the points. So sort of list the points, and hopefully they are in the right. Yeah, so I can see in this pop-up thing here that n equals 4. So that's giving me 0, 1, 2, 3. I think if it was 0, 1, 2, 3, 4, I'd have to cull it. So I think n equals 1, which should be fine. Or actually, I don't need to cull it for this example. So, and then I can, so I've got my 0, 1, 2, 3 on the original surface and 0, 1, 2, 3 on the offset surface. You can turn that off. That's just points. You turn that off. And now I'm just dealing with just the points. So now, there's a 4-point surface. I don't know if I have to, yeah, okay, I have to use the number 4 rather than typing 4. But 4-point surface is a sort of a very easy way to create a surface, and I just need 4 points. And it works fine with 3 points if you don't plug in the last one. So I can use any of these points to create surfaces. So if I do, if I was to do all 4, I would just get the original cell. So 3 gives me a triangle. And if I use one of these points, let's say I use the last point, 3, that's going to give me these sort of slightly kind of almost like roof tile kind of geometry. And it's kind of interesting to mess with different organizations of this. And you can see the geometry up there. But we basically have 8 points, and do that. One thing also, just as a last point before we do this exercise, is if we use flatten on some of these vertices, we can kind of, or I need to double check how to do this because I'm kind of a little unsure. But if we use flatten, we can kind of like get these to sort of stitch together. And I'm going to check that out. But if people start on this example, it's quite a small little definition, but let me know if there's any problems. I'm just going to double check that and make sure. Actually, I have one. I think that I have it open. No, yeah, if people start, and I'll just figure it out. Actually, yeah, so if you look at the screen, this is what I was on about. You don't actually need any flatten. It's just connecting the right points to the right points. But you can kind of connect it so that they kind of move almost as if they were solid panels. So if I was to bake that, I mean, they are still separate surfaces, each little thing, but they would render as a continuous surface moving around. And for the example I did in the PDF, it's just about creating multiple surfaces, 5 different surfaces, and you could recreate exactly what I did in the PDF later. All right, so next week, we're going to do vectors and fields. And yeah, that'll be great. All right. Thanks for everyone for joining.